I had some stuff arrive, so I thought let's do something that I don't normally do and do a post bag type of thing, but then we'll take some of this stuff apart and see what it's like. Now the reason there's a couple of solar panels here and this solar panel here is because recently I mentioned in a quiz question about the cadmium sulfide photocells, and I was looking while researching it. I noticed that there's a solar technology called cadmium telluride, and I was trying to find the flat panels. I was hoping that these were these, but I think these are silicon by the way they're made. I tested it in sunshine, 5 volt output, 700 milliamp, nowhere near the rated power in the listing, but you know, I've looked at one of these before and it's what you expect. It does put out a decent amount of current. I'm not sure how fragile that is. It just feels, although they say it's flexible, I think there's a risk that if you bend it too far, the silicon strips would crack in there. Although I did make it through the post, which is quite impressive. I also got these when searching for the solar panels. Stuff popped up. So one of them is this little solar rechargeable light, which I've taken a look at before. It can also be recharged from a power bank or power supply. We'll take a look inside this at some point. But this solar panel, I couldn't really, well actually in hindsight, I could have popped the back off this, couldn't I? I could have popped the back off and just tapped straight into it if I wanted to actually do the test. Yes, a couple of connections here, but mostly air inside. Okay, so I could have done that, but loud click as I put this back in. This one just came with the jack plug-in end, so I tested it about 122 milliamp, which is what you'd expect for strips of this size. And this one, I'd guess, is going to be around about 100 milliamps probably, which is reasonable for that size of cell. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 6 volts. That's why they're kind of using it to charge the battery in that device, which will be a lithium cell, I'd expect. This one has also got the 12 panels, so roughly 6 volts. Useful. Put that out the way. Oh, it is the type that has them laid into plastic though, with resin over the top, so there always is that risk that with thermal expansion contraction it's going to crack that. Right, next thing to take a look at, this. It was one of the bundle deal things. Quite dangerous, but I thought it was quite clever. This uses a standard Stanley knife type blade or utility type blade. Well, I thought it was standard. And I thought that's quite useful because you could use it. It's designed to cut things very flush, very square. And you can also rotate this to different angles. So you can cut things like this fake LED neon stuff. You can cut it at very precise angles. One other application, I'm trying to think of applications for this. One application, if you turn it to the 90 degree, is that this is also this of like the LED neon type strip, and it has the marks at every roughly an inch. And if you put it in this, it would cut it nice and square. It does. It cuts through the little the bus bars on the strip as well. Quite handy. What else can I cut with this? Heat shrink sleeving. I'm not sure there's any real advantage to this. No, it doesn't cut heat shrink sleeving very well because the blade doesn't quite make. Okay, so not perfect for that, but then you'd just use scissors for that, wouldn't you? But I thought that was quite handy. It came with a couple of blades. I thought it was quite handy until I took this screw out and discovered, and I'll zoom down this so you can see it. When you take the cover off to change the blade, it has too big a holes in it, and they line up with these here. Now there are little end stops up there, but this is presumably so that as you cut something sort of sticky or resinous or whatever, it makes sure it pulls the blade back out again. But that means you can't use standard blades in this. It's going to have to be ones with these holes. Don't know where you get them. Don't know how you'd describe them. I suppose you could grind off these little pips and just use an ordinary blade in, because there is a sort of end stop there. But that might render it completely rubbish. I'm not really sure. Mind you, if you can't get the blades, it is completely rubbish. Anyway, but it's an interesting thing, and it does have possibilities, particularly for cropping this stuff, because it makes it nice and square, and that's quite useful with that material. It also has a safety feature, apart from this blade chopping up and down, that you can just flick this and it locks it. But it's an interesting thing. It was cheap. It was one of the bundle deal things. Rightio, I shall zoom out again for the next thing we're going to take a look at, which is these propelling pencils. Why did I get propelling pencils? I was more interested in the large pack of leads that came with it. I can see some are broken. It comes with, you get 2 pens and 700 leads, which just seems quite a lot. I'll use this little knife here just to slit the tape on this and open it up. Comes with little boxes for them as well. That's interesting. How strong are these? I wonder, are these... Let's bring in the meter. Let's measure the resistance. Is it going to be high? I shall place that on there. Quite low resistance. About 43 ohms. 40 ohms, say. That's interesting. I wonder what happened to a pass current through that. You know, it's getting... The voices are saying pass current through it. Hold on. Let's get the bench power supply on and carefully grip that end. Is this just going to break? It is going to break, isn't it? Let's see if we can make it glow. 13 volts at the moment. Oh, there's smoke coming off it. That might be the binder. Interesting as a little heater. There's quite a lot of smoke coming off it, actually. It's currently dissipating 13 watts of power, so I would expect it to glow. Is it glowing? Hold on, let's zoom down on it. Lots of smoke still coming off. The smoke is reducing. The current is going up. Let's take the exposure off and turn this off and see if it is glowing. Yeah. So there you go. It glows. Watch your eyes. The light is coming back. The light is back. Okay, let's not melt these. Useful to know. I'm not sure how that will write now that it's been thoroughly grilled. I should actually be careful about picking this up. Oh, it's got a... Yeah, interesting. Another interesting thing about these little pens, oh, the leads have gone into the hinge, is that they have the child safety cap, so if a kid swallows it, it's not going to... It's got a hole right through it. But the end pokes right through, so it's not really a great safety cap when you can write right through it. But there we go, it works. I chose the one with the thickest leads because it just seemed that it was going to be stronger and they were going to arrive intact. Right, that's that out the way. This is another thing I got, just a little knife. I just threw it in, it was only about $1 extra with blades. It was just cheap and I just threw it in. What next? Right, we have this little thing. I'll stay zoomed in for this because it's quite small. It is a charger for the 2032 and other type cells. Interesting approach to it though. That it's got this little thing that lifts up and it's got the contact underneath so you can lay a cell in. I'll just lay in a non-rechargeable one, I presume it's like this. And it just clamps down it for charging it and then it's got little charging indicators. And USB-C by the look of it. We shall take this apart. I don't think it's going to have any great surprises, but it's still worth taking apart at some point. Next, shove that in there. I'm sure there was instructions. There are instructions. Not that I really need instructions. I'll just put that out the way. Next is, and I'll zoom out because this is quite a big chunky thing. This was cheap. Everything is cheap. And I noticed these were being sold on AliExpress and eBay. Interestingly, I do have some other solar panels in their way that they're not cadmium telluride, which is the ones I wanted. Look that up. It's quite interesting, cadmium telluride solar panels. A direct competitor to silicon, but actually hobbled by that word cadmium, the toxic thing, even though there's a small quantity in it. But the other one that I may have on its way is SIGs, copper indium gallium selenide. We'll see what actually arrives. Don't know, thin film solar panels. Interest to see what their output is for their size versus silicon. And certainly they look more robust than silicon. So this is a solar charge controller and costs something daft like £2. And you've got the solar panel input, you've got the battery output, and then you've got the load output. And I've had a wee play around with this, and it looks as though you can program it for the type of battery. It could be lead acid, or the 3-cell lithium ion, or the 4-cell lithium iron phosphate type cells. And it can auto-detect that to a degree, but you can also manually change it from the menu. You can set the lower voltage that cuts the power off to the output, and then the voltage it will recover at. It's got the USB output, and it's also got the function that you could tell it from dusk, whether it's going to be 24-hour output, or you can program a time that it will power up for 4 hours at dusk when the light levels are low enough detected from the solar panel. Or you can tell it to be dusk to dawn, and it will turn the load on, lights or whatever, at dusk, and it will turn them off again at dawn. And it looks quite interesting. Let's open this and see what's inside it. I did power it up. It's got rising clamp terminals, which is nice, although be wary about the rising clamp terminals. You can push a wire underneath them and then clamp them up tight, and the wire will pop right back out again. It's just that style of rising clamp terminal. You just have to be knowledgeable about that. Same as with some main circuit breakers, which isn't great. This is metal. I wasn't expecting that. Oh, that's why. It's got the transistors in the back. Oh, I like the zigzaggy approach to the bus bar here. That's quite neat. Also other positions for more transistors. Is it upgradable? Let's whip these screws out. What is that out of? Oh, it's a quality control thing. The screws appear to be the same size universally throughout it. That's quite good. Okay, well, there's the microcontroller. Quite a lot of circuitry. The microcontroller is underneath the LCD display. It's soldered in. That's very annoying because the risk of damaging the LCD display while desoldering it is high because it's just those little glued on pins at the end. That's quite annoying. There's the USB boost circuit. Is this diode across the output, or is that going from there to the USB circuitry? I measured the quiescent current of this in standby, and it was 2 milliamps, which is acceptable. That chip is an MC34063A. That's the Motorola style chip that is used in car to USB converters. And what's that chip there? It's an LM358, which is a dual op amp. That may be used for voltage thresholds. Given that this can operate with different voltage thresholds, I wonder if it actually changes the reference voltage to that. Lot of components in here. Big chunky rising clamp terminals, that's quite nice. What's the catch? Why is it so cheap? Is it because stuff like this can crash, and because the charging is under microcontroller control, if the processor crashes in any way, it can potentially overcharge batteries. This is why if you've got lithium batteries, I'd recommend having extra protection on them. This is going to be a monster to reverse engineer, just simply because a lot of the components are tucked under that LCD display. That's annoying. On the other side, cost-wise, I guess this is a mass-produced thing. That's why it may be £2. It's just too cheap, isn't it? But anyway, that is something to look at in the future, and I'll work out how to program it and put the English instruction manual down below. Let's take something to bits. I wanted to take this to bits, but that's going to be very time consuming and it's quite late. So I'll just shove everything out the way here and say what's in here. It's an 18650. Is there any circuitry up the end? Is this just wedged up the end? Or is that just the USB cables coming down? It is just the USB cables coming down. Is all the circuitry on the blub? Let's get this off. Let's not get this off. Oh, that is on tight. And there's screws hold it onto the plastic on the other side, but the actual dome should come off. The dome will come off. The dome has just cracked. Oh, and I've also just like rubbed the blade into my finger. Right, tell you what, this is going to be loud and crunchy. Oh no, it's not. It's coming off. It's broken. That's all right. It was cheap, and I got it for fun. I got it for our exploration. It's still not really coming off, though, is it? Do I have a flat blade I can prise it off with? This isn't a very big flat blade. And that's just LEDs. That means there's more circuitry up the other end. Oh, there are some screws at the other end. Didn't spot those. So we got a little circuit board. Oh, incidentally, click full brightness, click low intensity with the pulse modulation only visible in the camera, and brace yourself, it's going to be strobing. Does it have SOS if I hold it on? Hold it in continually, is it going to do? Oh yeah. Gimmicks. I thought the circuitry was going to be down there, but it's not. It's up here in the head. Let's get this little clip off. I've undone that. Glue, wires. There's the circuit board. Right, tell you what. I shall pop that circuit board out and we'll take a look at it. One moment, please. Reverse engineering is complete. Let's explore. I shall zoom down just a little bit here. Oh, too much. Very delicate zoom, yes. So here's the USB port coming into it. It's got a green LED for the charge circuit, which is an LTH7 and a 2K programming resistor for roughly about 500 milliamp charge current. Couple of decoupling capacitors, one on the incoming supply and one on the output. It's got the button signaling to this little chip. Now the chip is odd because see these empty resistor positions, they're for potential dividers. And yet the pinout of this chip matches another sort of generic one. Strange, I'm not sure, I've not come across. I would guess it's for programming modes, but I don't know if that's used in this chip. Maybe it's to give other options. And the only other oddity here is that the output to the LEDs, has a 10K resistor across it. Strange. Anyway, let's take a look at the schematic. Oh, incidentally, here's the LED panel itself, no resistors, but having said that, I think the lithium cell might have a bit of a high impedance, and so they're just in parallel, 20 LEDs across that when you turn it on. If we take a look at the schematic, there are no great surprises. It's a very classic schematic. I shall zoom in this a little bit. Big zoom, yes, that's fine. It's a good enough zoom. Now, the lithium cell is currently under test. I don't know the capacity. It's marked 1200 milliamp hour, but when I put it on my bench power supply to charge, I set it to 4.2 volts, and the current went up. Initially, it was capped at 500 milliamps. It charged at 500 milliamps, but then it sat for ages, and I mean a very long time, at 400 milliamps, to the point I thought maybe the cell is an internal short. That could have been hinted at by the fact that they've soldered onto the cell onto both ends, which isn't normally recommended. I got the thermal imaging camera. It was not displaying any sort of heat signature that I'd expect, heat at one end where there was a short internally. And I left it on charge, and it gradually, well, after a long time at 400 milliamps, it then started in its downward trend. So I think it is just an internal high impedance. But we'll find out. It is under test now. It's discharging now. But the internal impedance might be a factor in the discharge. It may actually kind of end it prematurely because of that, because it reaches its target voltage, which I've set quite low at 2.6 volts to terminate the discharge. So here's the USB supply coming in. It's got the decoupling capacitor there. It's got a 270 ohm resistor for the green LED on the LTH7, a very classic charge control chip. And it's got a 2K programming resistor to set the current that it charges a lithium cell with. There's another decoupling capacitor on this side. There's the chip. Now, it's marked JD53C. The closest match I could find for the pinout was L267, which just shows 4 pins connected, but there are 2 extra pins with resistors that are not populated. Quite strange. There's that odd 10K resistor across the LED. I wonder if there's ghost glowing through leakage internally. I'm not sure why they've done that. And then there's a little clicky switch which selects the modes. I think this is just a standard flashlight chip. Well, that took a very, very short time to describe. It took a lot longer to reverse engineer, but that's how things normally go. It is quite an unusual little light. Nothing particularly special about it. It does have the potential to be useful. The fact it can be charged with solar power or USB, and it's nice that this one does actually have. Oop, I'll turn this around. It's nice that this one does actually have the LTH7 charge control chip. But I'm guessing also that the LEDs are clamped straight across the battery via this chip. I don't know. I don't think this is internal current limiting. Normally it would be used with an external resistor between the control pin and the LEDs. But I think ultimately the voltage of the cell is going to drop because of its internal impedance. I'm not a huge fan of the use of lithium cells like that. It seems almost like abuse. But having said that, they do it with many cheap lithium cells. I didn't test the current. And now the cell is currently being discharged. I'll try and remember that. But certainly the capacity of the cell, it's in progress, the test. And I'll leave that result down in the description down below. But there we have it. The solar chargeable little LED light, complete with its slightly mediocre solar panel. But in sunny climates, it would take enough charge during the day to actually make a decent, put a decent charge into that cell and make it a fairly useful little camping light, but only if you had lots of sunshine. But that's it. An interesting little thing, and let me know if you can think of uses for this strange cropping tool, or where the blades can be got from in that particular style. Maybe there's a code or a number for them. But that's it. Interesting devices, interesting mail, interesting solar panels, and quite fun to take this apart, even if it was fairly standard circuitry.